Hi, welcome back. We're starting our week after the 2-week circuit breaker, so don't forget that we have in-person recitation scheduled for Thursday and Friday this week, along with the normal Zoom ones. Anyway, we're back to what was our original schedule. I want to continue talking about writing classes and using them. And in particular, this time I want to talk about what happens when we start passing objects to methods of classes, and are there any special rules that apply there? So I want to develop some examples where we see objects being passed as parameters, and in particular objects of the same class. So we might have a circle class method that takes a circle object as a parameter, and then to see what the usual Java rule of passing by value parameters, in other words, when you have an argument and a parameter, it's the value that gets passed between the two, means in this context. All right, so first I want to review, again, this very important concept from last lecture, the non-recitation lecture, on encapsulation. And encapsulation is, again, this idea of hiding the internals of the class, and it is implemented in two main ways. One is there are private instance variables of the class, and there is a public interface. And those two things, I think, have two main purposes. One is to prevent this data from being changed in a way that's not expected or allowed. In other words, to have a consistent internal state. For example, someone in another class could decide to make this a negative radius if this was a public instance variable. And maybe there's code that really depends on that being positive in the class, and rather than having to check for it, we just control access to radius and make sure that it's always set to be non-negative. So anyway, by making these public, you would then open it up to unexpected changes, and you really can't predict what people are going to do to your code, so it's best to leave these private. The other is to kind of control how other code works with this class. So we saw an example where, for example, we had a get radius here, and by making the internals private, we could change that internal representation from a radius to a diameter, and then we just changed sort of the math in this get diameter and get radius, and it all works out, and all the code that calls this, that uses this class, other code in other classes and other files, don't have to change, right? The interface stays the same, and the internal representation changes as we desire as we're developing this class. And again, if this were public, people may still behave nicely in the sense that they don't do anything illegal with that instance variable, but it prevents us from easily changing this representation from a radius to a diameter. Otherwise, we have to go to all that code that in other files that access that and update it there as well. So this idea of encapsulation really helps control both code changes. So if you, as a software developer, you're working with a team, it helps kind of limit where things have to change to a small area of the code, which is really great. But the other main purpose is then to make sure you prevent unexpected things happening to the internals of the class, or the objects of the class. So again, here we have this private internal data, private instance variable, public interface, get diameter, get radius, and we can provide whatever interface we want as long as we can derive it from that internal data. Now, just to remind you, this constructor here has a parameter, initial radius, and in this code here, the code of the method, the scope of it allows us to access the parameter, because that's in scope of the constructor. It also we're also allowed to access the instance variables of the class. That's also in the scope, the class scope, basically. And if there happened to be a local variable, which there is not, that also is in scope and can be accessed. So before we sort of had two things, the local variables and the parameters that could be accessed in the scope of the method, but now there's a new thing, this instance variable. And this is both a convenience and a little bit of a curse. It's a convenient in the sense that it's nice to have a bunch of things up here that don't have to be passed as parameters of the method. And you just know when you call a method that it's going to work on those internal values. The bit of the curse is that it's a little hard to figure out what's going on, right? You have to realize you have to look up here and find this thing defined in the class body, not just in the method body. So there's like this larger area where you have to look. And really, to be honest, when you look at a class code, you're really trying to look at it as a whole, right? They all work, all these parts work together, and your job is to figure out, what is the purpose of this class and how can it, help me in my code. Whereas with a method, more often it's more doing one specific thing. And so again, it's sort of this larger stuff you have to look at and get used to looking at. So just keep in mind, let's see, that again, this is a primitive type, and that means when we make an instance of the class, so C1 is the name of the variable, it is of type circle. We call this thing an instance of the circle class. It is a new object of the circle class, and we define it by using the new keyword and then calling the constructor of the circle class. So this 5 value gets passed by value to this parameter, and initial radius is assigned that 5 to start off, right? That's what pass by value means. It's the value of the argument. In this case, it's a literal, so it really is 5. It gets sent. This could have been some sort of other variable, and then again, the value is extracted out of this expression and sent up to the setRadius method. And of course, this can be some new expression as well, some larger expression, right? So as long as it evaluates some value, that value is what gets sent up to the class. Okay, so here we made a new circle. We printed out its radius. The only reason we were allowed to use .radius here is because main is part of the circle class, and so it has access to those private instance variables. If this were a main in another class or a method of another class, we would have to use that get radius getter to access the radius. And here we are using the setter to change that internal stored value of C1. And then here we are using a getter, get the diameter that returns the radius times 2, and then that gets printed out. I'd like to keep one other thing in mind that's important here, and that is that if I make another instance of the class, let's just make it size 1, and I printed out the radius, and let's use the getter here. In some ways, it's good to work within the interface you've defined for the class. So let's see, let me just get rid of that, and I will. Okay, we have 2 prints. One is printing the radius after the radius was set to 2, and the other prints the radius after we construct it with a radius of 1. And we print out the 2 and the 1. The reason I'm doing this is because here we have 2 instances of the class. The important thing is each one has its own storage for the radius instance variable, right? So just like 2 arrays each have their own storage for a bunch of elements of the type of the array, in this case 2 circles have different storage for their own instance variables. These are 2 distinct circles. Changing one doesn't change the other. Okay, now one point of confusion is that in this case we're passing these primitive types around, and of course we can also pass objects as an argument and received as a parameter in the class. And let me start with a simple example and then do a slightly more complicated example. So here I have a string ID. Maybe this is a circle in some sort of design package, and it allows you to name the circles or have some ID so that you can select them somehow more easily. So it's not uncommon for these kind of things to have some sort of name or something like that. I'm going to make a setter. We'll just make so the constructor, if it doesn't set it here, it's just going to be default initialized, and we should find out what that is going to be. So let's, for example, is it an empty string or is it null, right? So here I'm going to print out the ID after constructing circle 1, but not setting what that string is. It's a little hard to tell. Let's because if it's like empty string, we can't see it, right? Let's debug it and look at C1, and its ID is null. All right, so that's what I thought. Every object, for example, if you make an array of strings, each element is null. So there's nothing in there right now. So I always forget to stop this, and then you sort of start editing it, and it gets weird, right? So make sure you stop things. All right, so we want to have some way to set this ID to some meaningful value, and I'm going to do that with a new setter down here. So that's going to be public, and it doesn't return a value, it changes the internal state, one of the instance variables of the object. And I'm going to say set ID, and it's going to take in a string ID. And what do we need to do here? Well, first of all, let's get ready to call it. So c1.setID, and I'm just going to give it like an ID number 1 or something like that, right? As a string, it's a string type, so even though it's a number, it's a string number. Here, I want to set the instance variable ID equal to that parameter. And last lecture we talked a little bit about how you need to disambiguate this. In other words, if I say this is saying use the ID parameter to set the ID parameter equal to itself. And this error here is saying this has no effect, because if you assign x to x, then it doesn't change anything, right? So here we're not accessing the instance variable, because when it tries to figure out what this ID is, it says what's the closest scope that contains ID, and it's this one, because the parameter belongs to the method scope, and so these all reference this particular ID that's referenced here. If I want to disambiguate this, in other words, figure out or force it to look at the instance variable, I use this keyword. And again, this is the object that calls this method. So here, when C1 is calling or invoking the setID method, C1 is assigned to this just during that one call. When it leaves, this is now ready for someone else to call it. And if C2 called setID, C2 would be assigned to this, which means we're getting at the instance variable here, right? So again, one big change is that when we call a method of a class, then you need to invoke it from an object, an instance of the class. So it's the instance dot name of the method, and at this time all these instance variables here, radius, all that stuff, are the ones that belong to this object here. If C2 were to call the method setID, set it to 2, then when C2 calls setID, and you get into setID, the toString gets assigned to the parameter here, and this instance variable is the one that belongs to C2, right? So again, it's important to remember that each one belongs to a specific object. And if you don't have an object calling this thing, it doesn't know what the instance variable is because it hasn't been constructed. So you can't call this sort of by itself, right? What would that mean? You know, set it on what object? And so you can only call these methods, these non-static methods, from an object. All right, so the other thing that's important to remember here is that this string is an object. When I call set ID here, it is the reference to this string that is used to initialize ID. So ID here and this toString are both really the same object at that point. And then I assign that reference to the instance variable. And now this object C2, its ID is a reference to this string here. Okay? So that's what passed by value means in this context. It's the reference that's passed by value and used to initialize this thing. And now they actually look at the same object. So that's nothing, it's nothing too weird there. And in particular, strings are actually immutable, means they can't change them, and so it's hard to have any real effect because of this pass by reference. Let's add a method to compare two circles. And you know, this might be used like in game engines, for example, when you have sprites running around the screen, you want to see if they overlap. It's pretty common to do some sort of testing, like do these two circles overlap? And sometimes you just want to check, like, is one bigger than the other for various reasons. And so it's pretty common to compare just sort of the geometry of these two circles. It's used. This is an operation that's used a lot in, like I said, in games and other kinds of things. So I want to see if one circle is bigger than the other. What does that mean to be bigger than the other? It just means its radius is bigger. So you know, when we're saying, hey, is circle 1 bigger than circle 2? Then all we really want to keep saying is circle 1's radius bigger than circle 2's radius? So that's how we're going to implement this method. So this is a public method, and it's going to return true or false, right? Is the first one bigger than the other one? So the return type is bool, and I'm going to call this is bigger than, which looks kind of funny here, but at some point we're going to call it like this. We're going to say, it's going to print something out here. We're going to say is C1 is bigger than C2. And that's going to return a true or false, basically, right? So I write is, you know, I might say if C1 is bigger than C2, use it in an if statement kind of thing. Here I'm just going to print out true or false. So it looks kind of all alone here, but you have to kind of think about how it's going to actually be used, and then you can kind of read it as a sentence. And it's nice when these things read in a way that you can just sort of read it out loud and understand what the question is. So in this class, we're going to ask if a circle is bigger than the circle that's passed to it as a parameter. So there's only going to be one circle here. I'm going to call it other. And when is it true that the first circle is bigger than the other circle? It's bigger when radius is bigger than other radius. Okay, so what does this mean? There's sort of a lack of symmetry here that's uncomfortable for a lot of people. Where did my circle go? Oh, here. Okay. So this says, is C1 bigger than C2? C1 is bigger than C2, and that's either true or false. C1 is the object that calls the is bigger than method, which means that if you just have an instance variable here, that belongs to the object that calls the method. It belongs to C1 in this particular case. I could put this in front of this, and again say, what is this? This is the object that called the method, and C1 is the object that called the method. So this is saying C1's radius is bigger than the other radius. Where does the other radius come from? It comes from this object, C2. C2, its reference is passed to here, other, and it's accessed in here. Now, some people are upset in some ways, not upset, they don't, it's confusing, I think it's a little confusing, that, excuse me, here we can obviously access the instance variable of the method that, of the object that was calling the method, so C1's radius. But you know, we're saying it's a private, radius is private, so why is other able to access radius directly instead of calling the getRadius method? Well, this is code inside the class, right? And we can access all circle instance variables inside this class. So there's nothing special about other belonging to another object. This is all part of the class code, right? So you have to sort of think about, sometimes there's a difference. Sometimes you're looking at that class code, and sometimes you're thinking about what object is being worked on as part of this class code. Now, I would say it's not the worst idea in the world to use the getters that are provided here, especially if there's nothing too funny going on, like, you know, changing values or anything like that. And now this code is also a little more resilient to later changes if we ever wanted to change radius back to a diameter or something like that. I have mixed, you know, I'm not against using the instance variables directly. Sometimes that's sort of, you want that raw value maybe without any processing, but other times if you have an interface defined, go ahead and use it. No one's complaining about bool. Boolean. In C it's bool. So now again, you have to match up. You only see like one circle here, right? This parameter. There are two circles here. One is the circle that called the method, this, and the other one is the one that gets sent as a parameter. But you know, again, it's not like we're going to send circle C1 and circle C2 here. There's not two parameters here because that would be now three circles involved. And so don't do it like that. So that's pretty much it. Notice, yeah, so even though it seems like a little bit of a special case inside a circle class to have a circle parameter, it's just treated like another circle. And we can either access instance variables directly or we can just call methods on it. But sometimes it helps to have this here, and sometimes, what does this mean? I'm calling the getRadius method, which I know belongs to whatever instance called this method here, so I can just call getRadius. I don't need there's an implicit this in front of it, and it's optional. And you should get used to, most people treat it as not usually written. So you'll see a lot of code that looks like this, right? So in this case, C1 called is bigger than. When it sees a method here that's part of this circle class, it says, all right, it's being called from the same object that called this method here. So that's really C1 getRadius on this side. And again, this makes it a little clearer, but you're still not sure what the name of the thing is, like you know where C1 came from. But again, it's the reference here gets assigned to this. All right, so we're adding little bits and pieces to these classes as we go. But it's important, the hard part most people have with is this idea of these instance variables belonging to their own objects. C1 has a set of instance variables, C2 has a set of instance variables, and then some of the way you access things in these methods takes a little getting used to, partly because, again, some of the information might be way up here about what things are instance variables, and some of the things may be coming in as parameters, and some may be local variables. So there's just a little more stuff to track. But the good thing is when you write these things, they're quite nice to use, right? You just say, hey, give me the radius, or test this kind of stuff, and it's sort of self-explanatory, more than a method that's hanging out by itself, a static method that kind of needs a big Java doc to explain what's going on with it. All right, that's enough for now. We'll practice some of this in the lab as well.